that's why I haven't prepared a slide for that. So yeah, coming back to the topic. So introduction, basically three characteristics of minting process is in general, like first is scalability, which is for minting process in terms of cost and throughput. Uh, then comes durability of the NFT. Actually, I'm getting some noise. So if you can turn off your mic, will be great. Thank you. So immutability of NFT and assets that represent and prevent unwanted changes and malicious actors from changing the digital assets. So yeah, Polygon is generally used for scalability characteristics with their protocol and framework. So yeah, they can also they are also compatible with Ethereum and its virtual machine. And likewise, NFT.storage guarantee durability with the power of underlying Filecoin network and immutability by using IPFS content addressing. So what all prerequisites you will need in this walkthrough? Yeah, somebody's saying something. Okay, maybe some noise was there. Okay, good. So you should have some basic understanding about what NFT is in general. You should have Node.js background. You should even have MetaMask installed in your PC or in your browser extension, whatever. Then you can even go and make it compatible with Polygon Mumbai testnet, so that we can even do things on Polygon Mumbai testnet. So what you can do, you can even take some faucet Matic into your Polygon Mumbai testnet account via Polygon faucet. So yeah, let's start with the tutorial itself. Okay, I'm again not able to share the screen. Can you give me access? Uh-oh. Okay.
Can you hear me?
Yeah, I can share now. Thank you. And we can start with the demo itself right away. So like I have given you a basic repo of this. Similarly, I will be using it here. So like what all things are there? There will be Hardhat ethers file is there, which is a development environment for Ethereum and blockchains which are compatible with EVM like Polygon. Then open zipling files, we will be using a collection of smart contracts featuring basically standardized NFT based contracts. Then we will be using NFT.storage, a library to connect NFT.storage API, which we will be getting it from NFT.storage directly by logging in via your YouTube account or your any other account. Even we will be installing .env file, which is basically a library to handle environment files for configuration. Examples, injecting your private key into the scripts. So we already have that things in our packet.json file. So we just have to install it via npm.install. And here we go, it's done. Like I have already done this just because it is quite time consuming. Now, what we will be doing, we will create our hardhat file. So if you are not aware of hardhat.config.js, and if you have never used it before, I'll keep it very simple for you guys so that you can even do it further. So what all things you have to do? Okay, yeah. Before that, you should have a env file. Like I'm not sharing mine because I have already pasted my private key from my MetaMask wallet, which is already having Polygon Mumbai testnet, and it has some Matic into it. So for that, you can even check out faucet dot polygon.technology. So from here, you can get some Matic into your Mumbai testnet account. And yeah, let's begin. So now, and secondly, sorry, I forgot another thing. We even need NFT node storage API. So either I can share it and show it to you, or you can just go to NFT node storage, or I'll rather show it to you. No worries. Share again. Give me a sec. Where is that file? Okay, now we will be going to nft.storage. We will be logging into, I'm logging into via my GitHub account. Okay, it is taking some time. Logging, redirecting, okay. Okay, yeah, we have logged into it. So we just have to go to API keys, and okay, it's taking time. I'm not sure why. So you can create your new API key. Like I have my already existing API key. I just have copied it and pasted it into my Visual Studio Code file, which is here. I'm not showing it just because my private key is also there. So yeah, you can just paste it in your private API and you are good to go. Then we are further going to hardhard.config file. So for starting hardhard.config file, you should have few things. First, you should have a nomenclature hardhard ethers file. Then you will require .env file because that is where we will be getting the env file details. Actually, I'm getting a feedback. I'm not sure why. Okay, let it be. So then we will need our private key, which is stored in our env file. So for that, we will be creating I'm getting feedback, sorry. Okay, so just process.env, so it will be calling env file and whatever the private key mentioned there, just like here. So that will be called by that particular file and it will stored into this. Then further we have to export modules. Like here we are using Polygon Mumbai testnet. So we will be exporting our module, and default network we will be keeping it as Polygon Mumbai. Then we have to specify the details. So for the details, what I'll do, I have copied it from the Polygon website. You can even check it out. So for network, hard, then Polygon Mumbai, like I have already mentioned it here. So we will need its URL. So I have taken a dedicated RPC. You can even take any other Polygon RPC present on their documentation. And I'll calling the private key, which is stored in .env file. So it will be called here. Then further, we will be defining the Solidity specs, like the Solidity version for the smart contract. Like we will be using the latest version of Solidity, which I guess is 0.8.12, but maybe a new version has come into picture. Then we are using optimizer enable true, so it will be optimized at this range and stuff like that. So we will be storing the hard file. Now we will be coming back to our smart contract creation. So basically, or before smart contract creation, let's do something other, like for a file for storing your this particular asset, which I have already copied it, basically a buffalo. So for that, we have to write down the specs. Okay, I'm not sure you're able to see, sorry. So what I was saying, this particular buffalo image, so we will be it down for storing this on IPFS. So what we will need, we have to import nft.storage file from nft.storage. Then we have to import file system, that .env file, and .env.config we will be needing. Then we have to store our API key and bring it from .env file. So yeah, like if you see in the example, it is named as NFT storage API key. So okay, where is that file? Store. Okay. So I'm just calling it and storing it in API.key for my further use. We can even do console .log and print this API key for checking further things, but we will not do it right now. If any issues will be there, then we will be doing it further. So now for storing our asset, I have created a store asset function. Then there is a client which is calling, which is having this API key token or key from here, and then we are storing metadata from client.store, and its complete metadata is present here. Now we have to even do the, like, whatever things we have to print it off after it store assets on Filecoin. So for that we have console.log, and metadata is stored in Filecoin and IPFS, and its URL will be present there. Then further we have to call store.asset function to make it happen, and storing this particular image on IPFS. So this part is done. So I have like already done that. So what I'll do, I'll just, so it's done. Now we will do node script. Script is a folder here, and we will be calling this particular JS file. And when we will run this, so it will take some time, and it will store on IPFS, and we will get this particular message where we can see metadata stored on IPFS and Filecoin URL. And we got complete, our metadata URL. So we will need it further. But before that, we even have to deploy our contract. So before deploying, we have to create our contract first. So for creating your contract, we will be, like I have already said, we will be using the latest version of Solidity, which is 0.8.1. And the first statement which is required in any Solidity smart contract is pragma Solidity and its version. So we have returned that. Now we will be importing open zipling files. So here we go. So we are importing ERC721 because it's a ERC721 smart contract. We are calling ERC721 URI storage for storing it further, counters for storing it again and again, or like counters is just a file which just just a simple counters function like that is returned into that particular contract. For ownerable, like what could be the owner of that particular NFT. So for that, we will be using ownerable file. Now, we will be creating our contract, which is named as example NFT, and it's inheriting two smart contracts. One is this one and one is this one, and we already imported it and we already installed it, and it should be present in the artifact file. You can even check it out further. Now we have to call the constructor, and further we have to go for the mint function. So just we will keeping it very simple. And constructor is basically we are calling ERC721. So it's the original ERC721 which we have imported it from OpenZipling. Now we will create a function called mint NFT. It has address, it has the token URI string, and for string we used to write memory as well. And we will be giving it public only owner. So only owner is the ownerable function is there. Like only owner is the modifier. So that NFT will belong to that owner only, which will be minting it off. So yeah, then further we are incrementing it via the counters function. which is present in the counters.sol file in general. Then we are calling the mint function, which is this with the recipient and the new ID. Then we are setting the URI things, and we are returning the new image ID. So we are done with the smart contract as well. Now we will be creating deploy file. So for deploy file, what we need to do first, we have to create a function named as let me do it first. So we will create a function called deploy contract. So it is example.nft, and we will be calling the get contract factory, which is named like we have named it example nft. Second, when we will be calling nft example nft and deployed, so it will be deploying that particular contract. Now further, we even need the transaction hash on which it will be stored. So for that, we will be storing the transaction hash here. The transaction receipt, we will be getting it from the ethers.js library, which we already installed. And we will get the deployed contract address. We will be storing it here, and we will be printing it off via this console.log. And we are calling this deploy function here. Now let's save it and run npx. Like whenever we use these kind of modules, we use npm libraries. Hard run. Again, we are in script folder, and this particular file name is deploy contract dot like JS file, and then we even have to specify network and Polygon Mumbai. So if you remember, we have specified it here as Polygon Mumbai. So that's same thing which we need to specify here, and it will be deducting our Matic token present in our wallet, which we already stored it like our private keys here. So ultimately, it will be our Matic will be deducted from that account. Now we will be running it and deploying our smart contract. Okay, is on the label. Okay, so I have done a blunder. Like I haven't, just a silly mistake, I would say. So yeah, contract name was wrong. We will deploy it again. Yeah, it is solidly compilation is finished. It should be very easy and for deploying, just because we are using Polygon Mumbai testnet, which is quite fast, and it's EVM compatible as well. So you can even do it for any other EVM compatible blockchain or any other blockchains. Like you can even go further for different tutorials and stuff like that. Okay, so it's saying Solidity compilation finished successfully. Now it will be printing off the hash or the contract on which this particular contract is deployed, the contract address. So let's wait to make it happen. Okay, I'm not sure why it's taking so much time. Okay, till that time, or yeah, we have to be in line. So let's wait to make it happen. Okay, so till that time, what we will do, we will create a mint nft.js file. Okay, it's deployed. I mean, I have used a specific dedicated RPC from Polygon, this particular RPC. You can even, like, it's from Alchemy. You can even go for any other RPC present on Polygon documentation. So we will need this particular contract address as well as the file which we have deployed it, the file CID, which we have deployed it on IPFS or in Filecoin in general, because it's via nft.storage. So now we have to mint it. So for minting it, first we will need two things. One, our contract address. So this is our contract address. Is it correct? No, it's wrong. Okay, I'll copy it and paste it here. And second thing we will need is the CID. which is present here. So we will be copying it all, replacing it. So it's done. Next thing, what we have to do, we have to create a mint NFT function. So it's a yeah, it's a mint NFT function which has two placeholders. One is contract address and second is metadata URL. So with NFT example NFT, we are again calling with the ethers.js library. Then with the contract, who is the owner, we are getting that owner particularly so that we can get the signing thing stuff. Then again, we will be attaching it and minting it off. Now we have to call this function. So we will be calling it off here itself, just like our other files. So we have created a function we call mint NFT, which is here. We will be providing contact address and the metadata URL here. And it will call, if any error will be there, then it will go in the catch, or like it will go in a good manner, then it will execute all the things and your NFT will be minted. So now we have to mint our NFT. So for minting our NFT, it's quite simple. Again, we have to go with a simple command, which is npx hard run, because we are running it, same script folder and mint NFT JS file. Again, we have to specify the network. So dash dash network, and we have to specify the network name, which we have already like return it off in our hardhead file, like I've mentioned it before, this particular thing, and even we have stored it as a default. So when we will run this particular NFT, this Buffalo will be minting on, right now it's minting on Polygon, and it is using NFT.storage. So let's wait to make it happen and deploy and mint this particular NFT on our deployed contract via NFT.storage. So this process is running. So let's wait. Okay, it's done. So our NFT is minted, like we have mentioned in our mint NFT file, that it was printing the console log that NFT mint to and the owner dot address. So like I have used my private key .env file, and this is perfect my address. So this NFT is minted on my address, uh, and it's done. So in this conclusion, if I would like to conclude this particular tutorial, what I will conclude. So what you have learned in this tutorial, you have mint end to end. You have mint an NFT end to end with Polygon via NFT.storage, which is built on top of Filecoin. So this technology is a combination result of proper decentralization and guarantees of scalability, durability, and immutability, which we have mentioned already. So we deploy a custom smart contract to mint our own specific NFT as per like our needs. You can even change it. You can even do lots of things with this particular thing. However, you can even define complex logic that govern your own NFT lifecycle. I have just walked you through a very basic, simple ERC 721. You can even further go for ERC 1155, and it's a very good place to start further. Open Zipling is a great library. Like the security part and the contract wizards are crazy, so feel free to check it out. And this particular NFT will even available on OpenSea. So yeah, maybe you can check it out further, because all the standards of OpenSea metadata is covered here. And yes, and further, I would like to say, okay, just give me a sec. Let me know if my screen is visible. Yes, it's visible. Okay. So further, you can join our, Slack or Discord. For joining Slack, you just have to go filecoin.io/Slack, and you can even further join our Discord. So that is it for the NFT starter kit tutorial. Thank you from my side. And if you need complete, complete end of this tutorial, so even I can give you that part, which is stored here. So yeah, here you go. It's the complete demo. You can even try it out further and make some changes, do experiment it, and whatnot. So yeah, that's it from my side. If you have any further questions, drop it on our Slack or Discord. Thank you. And we are even open for Q&A. If someone have any further questions, you can drop it off in Q&A as well right now.
Thank you so much, Piyush. How was that session, everyone? Seems like only this group of people were involved in that session. How are you guys doing? Good morning. My name is Ola Benja. I'm going to be your MC for today, and I'm hoping that we're going to have an amazing time. Does anyone have any questions for Piyush? We still have some time. Anyone have any questions or anything you want to ask him before we go to the next session? Nobody?
And if you don't know about NFTs in general, so you can even check out nftschool.dev. It's a very crazy site and it's created by Filecoin team. So you can even check out how basically lazy minting works, and basic simple NFT tutorials are even present there. Even this tutorial will be available there. So you can check out there.
Thank you. Someone has a question for you before you go. Do you mind?
Yeah, sure.
Okay. Yeah, you can come up. Do we have another microphone? Oh, Piyush, he wants a link to the project you just created.
Sorry, can you repeat?
He wants a link to the report to the project you just worked on.
Yeah, I have posted the link in chat.
Okay, he said to join the Slack and he's posted the link in Slack.
Sure, I'll ping you in Slack.
Okay, they said they'll share the Slack link later to everyone. So thank you so much. Are we going to the next?